Hi there. Now in this question we're given the curve C shown here has the polar equation r equals 2 plus cos theta, where theta is greater than or equal to 0 radians but less than or equal to pi upon 2 radians. And at the point A on C, the value of r is 5 over 2. Now the point N lies on the initial line, and AN is perpendicular to the initial line. The finite region R, shown shaded, is bounded by the curve C and the initial line and the line AN. And what we've got to do is find the exact area of the shaded region R. So if you'd like to have a go at this question, haven't done so already, just give you a moment to pause the video. Do come back when ready and you can check your solution against mine. Okay, welcome back then if you had a go. So first of all, what I'm going to want to do is work out the area of the triangle OAN. And once I've done that, I'm going to go on to work out the area of OAC, and we'll give this part here a name, okay? We'll just call it, say, B. So I'm going to work out the area OACB, and then we'll subtract the area of the triangle from that and we'll get R. Now in order to work out the area of the triangle here, OAN, what I need to do is first of all establish what these lengths are, AN and ON. And to do that, what I know is that we've got R is 5 over 2. That's going to be this length OA. Okay, so I'll just mark that in as 5 over 2. I'm also going to work out this angle in here, angle AON. And I can do that by solving this equation when R is 5 over 2. So that's my starting point then, first of all. We'll just come down here. Okay, and so what we've got is that when, well, we'll just put A here, I think, okay, we're looking at A, and we know that R is 5 over 2. So we've got 2 plus cos theta, so 2 plus cos theta must equal 5 over 2. And if I subtract 2 from both sides, cos theta is going to equal 1/2. So cos theta equals 1/2, and if I take the inverse cos of both sides, it follows from this that theta equals the inverse cos 1/2, which is pi upon 3 radians. Okay, so let's just put that in here then, that this is pi upon 3 radians, the equivalent of 60 degrees. Now when I've got a 60-degree triangle, I should know the ratio of the sides. The ratio of the sides of a 60-degree triangle, 60, 30, 90-degree triangle, those sides are in the ratio 1 is to 2 is to root 3. So that means that if this side is 2 units, then for 1 unit that's got to be half of this, 5 over 4. So I've got the length of ON now as 5 over 4 units. And if this represents 1 unit and AN is root 3 units, then this side here, AN, is going to be 5 over 4 times root 3. So we've got 5 over 4 root 3 for that length. So now I'm in a position to get the area of triangle OAN. So therefore we've got the area, okay, of triangle OAN is going to equal half the base times the perpendicular height. So that'd be half the base, which is 5 over 4, times the perpendicular height, which is 5 over 4 root 3. 5 over 4 then root 3. And what do we get if we work this out? Well, it comes to 25 root 3 over 32. Okay, so we've got our triangle's area. Next I want to go on and work out the area of OACB. So we'll start with that then. Area of OACB. I've got to do this quite small because I want to get this all on the one screen, so do bear with me with this. I hope you can see this. Well, to get the area of OACB, what we need to use is the formula half times the integral of r squared integrated with respect to theta. And our limits go from theta equaling 0 right the way round to a, where we've now seen that theta equals pi upon 3 radians. So that's going to be up to pi upon 3. And if we substitute now for r squared is going to be 2 plus cos theta all squared. So we've got 2 plus cos theta all squared. And that's integrated with respect to theta. And the limits again then are from 0 radians to pi upon 3 radians. So next I'm going to expand the bracket. So we've got half then the integral of squaring the bracket then gives us 2 squared, which is 4, twice the product of these two terms, so that's going to be 4 cos theta. And then if we square the last term, that's going to be plus cos squared theta. And we're integrating that all with respect to theta then between 0 and pi upon 3 radians. Okay, now to integrate cos squared theta, I've got to call upon the double angle formula for the cosine of 2 theta. Remember, the cosine of 2 theta is the same as 2 cos squared theta minus 1. And if I rearrange that for cos squared theta, then what we're going to get should be familiar. It comes to a half of all of cos 2 theta plus 1. Okay, a standard technique when we have to integrate cos squared theta. Okay, so our limits again are going from 0 to pi upon 3. So if we just section this part off, so what this equals now is the half. And if we integrate 4 with respect to theta, we're going to get 4 theta. Integrating 4 cos theta is going to give me plus 4 sine theta. And expanding the bracket here, we've got plus a half cos 2 theta. If we integrate that, we end up with plus a quarter of sine 2 theta. And then we've also got half times 1, which is a half. And if we integrate that, we end up with plus theta over 2. And again, our limits are going from 0 to pi upon 3. Okay, well, let's just section this top off here, okay? So just run that through there. So carrying on then, what I need to do now is just substitute our limits in. So what we've got then is that this equals a half, and let's take 4 theta and a half theta. That's going to be 9 theta over 2. So we've got 9 over 2 multiplied by theta, which is now going to be pi over 3. Okay, so that's that pair of terms taken care of. And now if we substitute pi upon 3 for sine of theta, that would be sine of pi upon 3, which is root 3 over 2. So what we've got here is plus 4 times root 3 over 2. Then lastly, we've got a quarter sine of 2 times pi upon 3. And the sine of 2 pi upon 3 is root 3 over 2. And so we've got a quarter of that. So again, quarter of root 3 over 2. And then if we substitute 0 in, we just simply get 0. So we would end up subtracting 0 from that. Now if we simplify this further, what we end up with is 3 pi over 4 when we end up doing a half of this term here. And then if we add these two terms together and do half of that, you end up with plus 17 root 3 over 16. Okay, well, now that we've got this area and we've got the area of the triangle OAN, all we've got to do now to get the area of R, so we'll just say therefore area of R equals, is to take this area, 3 pi over 4 plus 17 root 3 over 16, and from this area subtract, okay, 25 root 3 over 32. And if we subtract that, you end up with 3 pi over 4 plus 9 root 3 over 32. Well, not the nicest looking answer, but hope you're able to get that one. If not, that you've been able to see where you might have gone wrong, or at least how to do it.